Okay, matrics, in this lesson, I want to focus on another example. I'm going to use a cubic graph that we sketched in a previous lesson, and we're going to find the equation of the tangent, this purple tangent, at x equals 1 to the cubic graph. And then I'm going to ask you to find the coordinates of the point where the tangent cuts the cubic again. Okay, now let's have a look at A, finding the equation of the tangent to this cubic at x equals 1. Okay, now remember, you could have been required to draw this cubic as you did previously, so you would get the x-intercepts. In fact, if you remember from a previous lesson, that was 0 and 6. And then the turning point, interestingly, the turning point was 432 in a previous lesson. I'm not going to do that, but that's what it was. Now, interestingly, the x value of where the tangent cuts the cubic is going to go through that turning point. You'll see, very interesting. But it could have. I mean, any other tangent could have gone, through any other points. But that's not the point here at the moment. I want you to focus on the x value as 1. So we've got the x of the points of tangency. Let's call that t there is equal to 1, and we want to determine the equation of the tangent at x equals 1. Now remember, what do we need? We're going to need, we've got the x of t, we need the y of t, and the gradient of that purple tangent. Okay, so we've got the x of the point of tangency, which is 1. It is going to be the x is 1. Now we need to get the corresponding y value, because that will be then a point on the tangent line, which is also shared by the graph. Then, of course, we can get the gradient by differentiating the equation of the cubic. So let's do this. How do we get the y value? Well, if we've got fx is equal to negative x cubed plus 6x squared, that's the equation of the cubic. Let's have a look at what is the f of 1. Okay, the f of 1 would be negative 1 cubed plus 6 times 1 squared. So let's see, what would that come to? Well, that equals negative 1 plus 6. 1 squared is 1, times 6 is 6, and negative 1 plus 6 is 5. So your y value is going to be 5. It corresponds there. Okay, good. Now, the gradients of the tangent. Well, if fx is equal to negative x cubed plus 6x squared, the gradient of the curve, or the gradient of the tangent, is going to be the derivative there, which is negative 3x squared plus 12x. Okay, and we want the gradients at x equals 1. So let's see, what is that going to give us? If we substitute 1 into the gradient, the expression for the gradient, let's see what we get here. 1 squared is 1 times negative 3 is negative 3. 12 times 1 is 12, and negative 3 plus 12 is 9. So that is the gradient of the tangent. Okay, so we can fill it in there. The gradient of the tangent is in fact 9. So we've got all the information we need to find the equation of the tangent. We've got x is 1, y is 5, and we can easily now substitute into the equation of a line to enable us to get the equation of that purple tangent. Okay, so let's have a look. How do we approach that then? Okay, we can say, well, y minus the y of the point of tangency is the gradient of the tangent, x minus the x value of where the tangent meets the curve. Okay, now what was that y value? It was 5, the gradient was 9, and the x was 1. Let's just double check that quickly. Here we go. X is 1, y is 5, and the gradient is 9. So we plug in the values here. So what would that give us? Y minus 5 is equal to 9x minus 9 if you distribute. And if you bring the negative 5 to the other side, it will be negative 9 plus 5. And your answer will be then y is equal to 9x minus 4. That is your equation of the tangent to the cubic at x equals 1. Okay, now what I want you to do now is I want us to go back to the little graph here. I want us to find the coordinates of the point over here, this point there in blue, where the tangent intersects or cuts the cubic graph again. Okay. Now remember, to do this, we're going to say, well, the y value of the cubic is the same as the y value of the tangent at that point. Okay, we don't know that it goes through the turning point. That's just my intuition, my feeling there. But don't worry about the turning point. It's where does the tangent graph cut the cubic. Now, how you do this is you say, well, what is the equation of the cubic graph? Well, let's have a look. The equation of the cubic is this, negative x cubed plus 6x squared. Okay, that's the equation of the cubic. The tangent has the equation 9x minus 4. Now they both share the same y value, so we can basically put them equal to each other here. So we say the cubic is equal to the tangent graph, and we're going to find the x value for which that happens, or x values for which that happens, and then we're going to be in a position to determine the coordinates of the point where the tangent meets the cubic again. Okay, so let's solve this cubic equation. I'm going to bring all of these guys across, so it's negative 9x plus 4 is equal to 0, and it'll be a good thing, let's multiply throughout by negative, just to make our life a little bit easier. Great. Now, what we can then do is we can test some values here. Some numbers that we can choose would be 1, 2, and 4 plus minus versions, and I'm going to try x is equal to 1. Let's see if that gives us a solution. So it's 1 cubed minus 6 times 1 squared plus 9 times 1 minus 4. Now let's see if that gives us a 0. Well, that equals 1 minus 6 plus 9 minus 4. And guess what? That is 0. 1 minus 6, negative 5, plus 9 is 4. 4 minus 4 is 0. So x equals 1 is a solution, which is great. It's an answer. So we need to create a factor. So bring that 1 to the left, and that gives us our factor. And we can now factorize the cubic. So remember what we did there is we said, well, let's write the original cubic down. There we go. There's our original cubic. And we then going to have a factor. And I'm going to do my little smiley face method. Well, x cubed over x is x squared. Check that. The first term, x times x squared, is x cubed. Then we have a missing middle term. And then negative 4 over negative 1 is positive 4. That gives us our last term. Negative 1 times positive 4 is negative 4. And if you remember with a smiley face, we connect the x squared terms. There we go. And we've got negative 1x squared plus the mx squared. Now, what is the x squared term here in the equation? Is this, and we want those to add up to negative 6x squared to give us our x squared term. Well, that's the same as saying minus 1 or negative 1 plus m is negative 6. And then we can say m is equal to negative 6 plus 1 is negative 5. Okay, so we can then go back and replace the m with negative 5 in our equation here, as we did. It's good revision of cubics, this cubic equations, and you can see how interesting this is. Then it's x minus 1 into x minus 4, x minus 1 if we factorize this trinomial here, and we get x is equal to 1, or x is equal to 4, or x is 1. So there, this is repeated, so that's okay. That is, in fact, that x value is where the cubic and the tangent meet for the first time. If you have a look at the graph, they meet for the first time at x is 1. So at this value here, this 4, which guess what, is going through the turning point, which is very interesting. Didn't have to, but x equals 4 would be the place where the tangent meets the graph again. So it's this x value that we are interested in. So all we now need to do is say, well, let's work out the corresponding y value. You can use remember the cubic and the tangent intersect there, so you could use either this equation if you want to, or you could say we can use the other one, the tangent equation. So what is the f of 4? Let's see, it's negative 4 cubed plus 6 times 4 squared, and if you then look at f of 4, that will work out as negative 64 plus 6. There's 6 multiplied by the 16. Now let's just do that in a calculator, and we get a y value of 32. Now if you wanted to, you could use the equation of the tangent as well, which was 9x minus 4. So if you plug in the x value of 4 into this, look at this. This gives you 9 fours are 36 minus 4, which is 32. So you could have used either the cubic equation or the tangent, because they meet. The tangent and the cubic meet at x equals 4. Okay, and we've got then, so what are the coordinates of where the tangent and the cubic meet? Would be x is 4, y is 32. That is the point where the tangent and the cubic meet again.